Okay, so it started recording now. We are looking at changing the formulae. So in this exercise, that was the first homework we had, was make x the subject. So we start with y equal to x. Is my internet connection, is that a bit unstable? Can you hear me properly?
It's all right.
Yeah, fine.
Yeah, you're right.
Yeah, so when we're asked to make x the subject here, there's two schools of thought. Some people would say, okay, I'll move x's on the left side, and sometime what I'll do, I just leave it the way it is, and I treat it like I need to get rid of whatever is next to x using the way we used to do it when we try to use the balancing method. In order to get rid of a multiply, we just divide by 2 because it was multiplied by 2. So divide by 2 both sides, that will get rid of the 2. And then you'll get y over 2 equal x, or you can just rewrite it as x equal y over 2. Or sometimes you see people even writing half of y. So it's the same thing. Half of y is the same as y divided by 2. Okay, so that's the first one. So that was an easy one. The next one is quite similar, but instead of having a positive number in front of x, I've got a negative number multiplying x. But you just apply the same thing. Dividing a number by itself just gives us 1, but we need to divide by a negative this time, and the answer becomes x equal negative y over 4, or a quarter of y minus a quarter of y. So all those answers are correct. Okay. I just like to write it with the numerator. Just get rid of the extra 1 there, because y times 1 is, and just leave it y over 4. Okay, on the next one, first thing first, I'm going to get rid of the add 2. To do that, we just take away 2, both sides. So then you end up with y minus 2 equals 3x. And after that, what I usually tend to tell my student is to put brackets where y minus 2 is. And that way you know that the divide by 3 on both sides is done over the whole section on the left-hand side here. So it's y minus 2 divided by 3. Okay, and
I love getting the x as far away from everything else as possible. That's what I would always do. Is go with the second solution. Just get the x away.
Oh, do you mean the second
so
solution?
I'd probably just get the y. I'd get the 2 across and just have the 3x by itself, because I know then I know it's divide, so I would at a time, so I know I'd divide it on the other side.
Yep. So what I've seen before is people adding just these wee brackets there, just to make sure that they remember to divide the whole thing here by 3. Or sometimes you can be asked to rewrite it as x equal, sometimes when we do like straight line, we write y equal mx plus c, for example. Here you can see it's like a bit of an my plus c. So you can see people writing it like that, but it's a third of y minus 2/3, or 2 over 3. So both would give you the mark here. The next one, I've got y and x on the same side. So then what I need to do to make x the subject, I need to get rid of the y first. So taking away y on both sides give me 5x equal 4 minus y, and then x equal 4 minus y divided by 5. So you can leave it like that. Or some people write it as minus 1/5 of y plus 4 over 5. So those are both correct. It's the same thing, written differently. The next one, I've got y minus 7x equals 3. So again, different technique. One of them would be to make 7x a positive. To do that, you need to add 7x on both sides. Then that means you've got to get rid of the 3. Then you need to take away 3 both sides. So it's a bit like taking that negative 7x, putting it on the other side becomes positive 7x, and taking that 3 from that side, bring it onto the other side, make it negative 3. So some of the school of thought there. Well, you can just say after that, you divide by 7, both side, y minus 3, divide by 7. That would be the answer for that one. The next one is to move 5x on the other side and y on that side. So you get 5x equal 1 minus y. Okay, and then that means x equal 1 minus y over 5. Or if you prefer to keep the minus 5x here, you would need to do y minus 1 equal negative 5x and then divide by negative 5 for both sides. And be careful, then you need to make sure that the y minus 1, you put a minus in front, which is going to give you a 1 minus y over 5. Okay. Then after that, it's just dealing with letters. So I just get rid of the a, taking away a. So just treat a letter as if it was a number. In this case, we've got bx equals c minus a, and then we divide by b both sides. Then you get your c minus a over b. And that
sorry, see for the ones D, C, D, E and F, see when you've got like your like say for question E, right, you've got y minus 3 equals 7x.
Yep.
Do you need to have that line, or can you just go straight to y minus 3 over 7 equals x? Like seeing a markable question, would that lose you a mark? Would that line be worth a mark?
So if it's a 2 marks, you won't lose the mark. So I can go straight from y minus 7x equals 3 to x equal y minus 3 over 7. So that would give me my 2 marks. Okay.
Right, okay.
But remember what I said one day, because it's 2 marks, you can still get a 1 mark if, for example, I had put here y minus 3 equals 7x, and then I made a mistake by writing x equals 3 minus y over 7. So you see that first line would give me 50% of my mark.
Okay.
Because sometimes you will see what happen is when we do a lot of math, after a while, you will see people making very subtle mistakes that they could have had a mark. I think the marking scheme is quite favorable for students. In the old days, you either had it right or wrong. There was no in between. But I think nowadays, someone can pass math even without having right answers at the end, as long as they show a bit of work in that.
Right, okay.
In between, they get something. So I would advise folks to put that extra line in case they make a wee mistake where they don't get the full 2, but they can still get a 1.
Okay.
But you will get the 2 marks if you get the answer straight away, right? Okay.
Okay.
Okay, and then for the last one here, I'm going to get rid of the m first. So to get rid of the m, I take away m. So that means 7p minus m. Again, I could have gone straight from this to 7p minus n minus m divided by 3n. I would have got here my 2 marks. But this step in between gives you an extra mark. Okay. The last bit there where I put or is just in case someone has written it that way, just to show that you still get the mark.
I quite like these questions. They're quite easy to understand if you sort of know your opposites to your plus, minus, your divide, times. You just try and navigate your way through it, and I quite like them actually.
Yeah, and I found as well explaining it, especially for my S1, sometime when they arrive, we try the balancing method, and then some of them picks up, oh yeah, I need to take away there because I've got an add, and then I need to add because I've got to take away. And then they get this wee method. Eventually, like you said, they can go and become quite good at it at the end when they're in the S4 or something, and they just skip all those steps. But at least it helped them from S1 going to S4, whereas in the old days, some folks would just not understand that, and they get to S4, and you can still see that they are struggling. Yeah. To give them a bit more help.
I think Unit 1 helped me a lot with that sort of stuff as well.
Yeah. And plus, it gives you an easy way to remember things. Let's say they don't do math for 4 or 5 years, and they've got this wee method in their head. Oh, I remember doing that balancing thing. That sticks into your mind much better than a rule, if you see what I mean. And then they'll catch up quicker.
No.
Okay. So for this one, again, we put this, and I just say to them, okay.
Phone BT or Sky. Is
it?
Then I've had problems with.
Resume recording. Yeah, so for this case here, we're just going to take away 6 on both sides first. Then you get your y minus 6 equal x over 2. X over 2 just means dividing. So the opposite of dividing is multiplying. And this time you see where those brackets comes handy, because you time both sides by 2. You time basically the whole y minus 6. Okay, so you can write it as x equal 2, open bracket y minus 6, or you can get rid of the bracket, but you need to write it as 2y minus 12. Okay. The next one, very similar, but it's with a 1 this time that you get rid of, and you time by 3. The next one again, I've got a take away 2, so the opposite of taking away is adding. So you add y plus 2 equal x over 7, and then you time by 7 both sides. You've got your 7 times y plus 2. The next one, I'm going to get rid of the negative y, because remember the objective is to make sure that we've got x on one side. And you've noticed here, instead of writing x over 6, they just wrote it as 1 over 6 times x, exactly the same thing. So I get y plus 4, then you time by 6 both sides, and you get your 6, open bracket, y plus 4, close bracket. Okay. And I would usually leave it with the brackets. It just means I don't need to do a 6 times 4, which is a 24. I've seen people a bit tired 6 times 4 and writing 28 and losing a mark, which is a silly mark to lose.
Just like I did with the surds in the Unit 1 exam.
Oh, it happens. I can tell you that. That's why they do say, you know, double check. It's always not a bad thing to just quickly go through. Next one, I'm going to get rid of y. That becomes a negative y on the other side. Then I get rid of the divide by 5. Okay, then that means 4x equal minus 5y. And for the last step, because I've got a time, I need to divide by 4. And like you said, some people can see that very quickly. The opposite of doing a 4 over 5 is doing a 5 over 4. So timing by 4 over 5, opposite of timing by 4 over 5 is to time by 5 over 4. So you can you know, you can miss those extra steps, but it's probably better to just step by step write it. Next one, first of all, I get rid of that negative 1.
Yep.
That means I add 1 on both sides. Then I've got x plus 5 divide by 3. So I want to get rid of the divide by 3. So usually people will get rid of the fractions first, right? Once you've got that this way, so you do 3 times y plus 1. And then you take away the 5. That becomes a minus 5. And that's why I had, in order to simplify, you got 3y plus 3 minus 5. So that is a mistake here. Oh, x plus 5 equals 3y plus 3. And my next step is x equals 3y plus 3 minus 5, which is 3y minus 2. Okay.
Yep.
Next one, you're going to get y minus 5. Oh, why did I put a 3 here? Oh, that's h. G we had done before. So I'm looking at h now. So 4x minus 3 divided by 2 equal 3 minus y. Then you've got your 4x minus 3 is 2 times 3 minus y. Then you just write 4x equals 6 minus 2y plus 3, which is minus 2y plus 9, or 9 minus 2y. Then you divide the whole thing by 4, and you get your 9 over 4 minus 2 over 4y, which is minus a half y. Okay. Next, got a few. So that was G. We did G from the previous one. Did we? Oh, this is G for this one. On the next exercise, we are looking at just now letters because they're used from science formulas. So the letter in the bracket is what they ask us to make the subject. So to do that, I've got divide by m. The opposite of dividing by m is to time by m. Then you get your mg equal m divided by m, which is 1 w. So 1 w, we just write it as w.
See, your subject, does it always have to be on the left-hand side, or is you still have your subject?
It's a good way. I wouldn't say it's a standard way to write it. You remember, you always write x equal. It's a function of x type thing. So here, when they ask us to write the subject as w, so you would eventually write it as w equal. Yeah,
Right.
you're right, because I could have said, okay, this is mg equal w, and stop there. But it's just a good way. You will still get the mark, to be honest. But it's
I've done a couple of them, and then I just done another line to then swap it over so that whatever the subject was on the left-hand side.
It's a natural, to be honest, to do when you've got quite a few and you've done quite a few. Eventually, you will write less and less as you go. But it's just, yeah, a good way to present your work, to say, I started with G as the subject, and now I've finished with W like they've asked me.
Yeah.
The next one, V equal RI. So that's, if you do a bit of physics, it's a very common one used in electricity. So it's just your potential here. Voltage, they call it, is the resistance times the electricity, your current here. So that's why it's V equal RI. Okay, whereas the first one was more to do with M for your mass and G, the, what they call acceleration, the gravity. Okay. And then you've got a force again, AM. So I'm going to write it as F equal MA by timing by A both sides. And then you have your subject. H, the height here with some energy. Yeah, E is the energy. So E equal mgh by timing by mg both sides. You can treat that as one. If you wanted to do step by step, you can say I'm going to time by m first and then time by by g. It's just as good as timing by mg. For this one, we've done that, E, and then F, very similar to E, but this time I'm going to time by t both sides. I'm going to have AT equal V minus U. And because we're looking to make U the subject, I'm going to say U plus AT equal V. And now I'm going to take away AT on both sides. And finally, you get your U equal V minus AT. Okay. So in this exercise, we were asked to, so we were given a formula, a maximum heart rate, H, and can be found using a formula. So where A is your age in years. So usually what you'll find is doctors might use some formulas given to them. You'll arrive, and when they measure your heart rate, etc., they'll ask you how old are you, and they'll plug it into their computer. So the computer just uses a formula, which is, for example, this one. if we're asked to calculate the maximum heart rate for a 30-year-old, so age is A, is 30. So that's the first thing we've been asked to do, is calculate H when A equals 30. So to do that, you just substitute A equal 30 into this formula, and that should give us 208 minus 7 over 10 times 30. Okay, and if it's if this question is a non-calculator one, you've got a 7 times 30 divided by 10. You can quickly do 30 divided by 10, that's a 3. 3 times 7 is 21, and then you just say, okay, 208 minus 21, it's a bit like 207 minus 20, and then it's just 187. So 187 beats per minute is okay. You know, it's possible. It's quite high, but it's a maximum. Remember, that person could be doing a lot of sports. So naturally, a person would be around at rest at 60 beats per minute. So you can see that the heart would be pumping quite a lot of oxygen here, because what it does, it just pumps the blood around the body. So the more oxygen your body needs, the quicker your heart will beat, okay? And that's why you get those 187 beats per minute. It's to keep you alive, otherwise you would just collapse during those high intense exercise.
Intense exercise, that's foreign to me just now.
That's a long time ago.
Exercise what? That?
Okay, and the next question, obviously they ask us to make A the subject. So heart rate is one thing, but now if we've got a heart rate which is quite high, we want to know what age the person would be. So that's why you're going to change now to make A the subject. So I'm going to get rid of the 208 by saying like 7 over 10 A equal 208 minus H. So I've just put 7 over 10 on the other side, this time 208 minus H. And then you time by 10 and you divide by 7 to get rid of a time by 7 divided by 10. And that's the formula there, done. So we've done A equal 10 time, open bracket, 208 minus H. Okay, so if I ask you, for example, how do I get age equals 0? So for a baby, you could say that it's just a newborn. 208, take away 208 will give me a 0 here. So you would say the maximum heartbeat for a newborn would be 208, which sometimes doesn't work like that. It's more for maybe adults if you think that way. But the next question they ask us is, we've got Anna, she's cycling on a bike. Her heart monitor indicates that she's at 176 beats per minute. And she's 46. Is she putting herself at risk? So basically, this tells us this is the maximum heartbeat that we should allow to someone. So if she's 46, the first thing we will do is we will replace H with 176 and see what is the maximum age that someone at that rate would be. Or you can put the heart rate here. You can use H and say this is 208 minus 7 over 10A. So you calculate that and you find out her maximum heart rate, the beating should be 175.8. So if she's doing 176, she's putting herself maybe into a little bit of risk if she maintains that. But she's just a bit about below it. So is she putting herself at risk? To maintain this, I would say yes, but so she's at 176. So you could respond, because 176 is higher than 175.8, then you can say okay. But if you rounded it to 176, you can say she's just reaching the max. Okay, so it's just, it depends on the interpretation. to me, I've put here 176 greater than 175.8, then she's putting herself at risk.
That kind of covers you for both of them, doesn't it?
Yeah, as long as you explain why the statement you've put is what it is based on, you're okay. If I was to make this question as an exam question, I would make it much. I would say she's at 190, for example. I wouldn't leave it open like this, because to me this is giving me both answers. As long as you explain the answer, I'm happy with it.
Yeah, I just left it at 175.8.
Yeah.
I quite like that, actually, doing it instead of 6.
Okay. So let's see the next set of homework. Yeah, so these were a bit more complicated because we started now looking at indices. So when you're given indices, how do you make a subject? So we looked at using again the balancing method, and we did say squaring, the opposite of squaring is taking the square root, cubing to take the cube roots. So this is where you can we are using cube roots and square roots, etc. So for the first one, I've got y equal x cubed. So to get rid of something put to a cube, I need to cube root it. So then that would mean x equal cube root of y. That would be my first answer. Okay. The next one, before we deal with the index here, we need to get rid of the 8. Okay, so think about BODMAS, but in the other way around. So you get rid of add, multiplies, and divide, and etc. And then you will deal with the index. Okay, so to get rid of the 8, we divide by 8. And that means I've got x cubed equal y over 8. And then after that, I take the cube root of y over 8, which is the same thing as cube root of y divided by cube root of 8. So now you're expected to know what cube root of 8 is. So what number do you time by itself and time it again, which will give you 8?
2.
Yeah, so you're expected to write this in its simplest form as cube root of y divided by 2. Okay.
See, I just left it at the...
Yeah, so that would be a 2 marks. And if you leave it at the cube root y over 8, you would get 1 mark, because they would tell you to and give your answer in its simplest form, for example. So read the question. Sometimes the question is pointing you towards what do you need to do to get the full mark.
So in that kind of question, I wouldn't lose a mark because it's not asking for that.
If it was me writing this question during an exam, I would put it in its leave it as in its simplest form. But I think the Nat5 committee, they expect teachers telling you during your whole year, make sure you leave your fractions always in their simplest form, for example. Yeah, so it's probably safer to make sure that you put it into its simplest form. But me, if I was to write this as a question, I would add that, just to point folks towards what they need to do. So I don't know who's writing those though, you know, during an exam or a prelim and stuff. If it's for my school, they would ask me my comment. If it's a national exam, sometimes we don't get the chance to say, but we do give feedback. Remember, those exams are used 5 years before even they are, given. So there is a committee that goes through them, and people are asked for their feedback. So teachers are asked for feedback, and someone might have said, "Oh, make sure you add that in." Okay. But this is a book. Remember, this is a book. So next one, I'm going to get rid of divide by 4 by timing by 4, both sides. Let's see. We've done C before, yeah. That's what we did there.
C. I think you're on D.
So we're on D now. We've done C and D. And then on E, I'm going to get rid of the 5, add 5. So take away 5 first. I've got 2 root x divided by 3. So I'm going to time by 3. So 3 times y minus 5. And then I'm going to divide by 2. Then you get your 3 over 2 times y minus 5. Or you could have written 3 times y minus 5, the whole thing divided by 2. And then after that, I need to square all this to get rid of a square root. The opposite of square root is to square. So I put 3 over 2 times y minus 5, the whole thing square. Okay, so 3 over 2 square, that would be 9 over 4. And then y minus... Sorry?
Why have you got brackets and then brackets? Can you not just have, do you still need to keep your inside brackets for that?
So at this point here, what I've done is I've squared the whole thing. Whereas you could have gone straight from here, instead of doing 2 brackets, you could have gone straight to, I'm going to square the 3 over 2, but you need to square as well y minus 5.
Right, okay.
So squaring 3 over 2 is to square the top and to square the bottom, which gives us 9 over 4. So your simplest form for this one would be 9 over 4 times y minus 5 square. Okay. But yeah, here you do need doubles. Sometimes people put like curly brackets instead of small bracket like this, or they put bigger brackets. I've seen that sometimes, people writing with taller brackets. Just my word processor here, so you can see sometimes people writing with a much bigger bracket, so they know it's the top bracket there. Okay, it's just the word processor that I'm using. Okay, and for the next one, I'm going to get rid of the 1 by adding 1 first. So I've got 5 root x divided by 2. Then I'm going to time by 2 to get rid of the 2. And then I'm going to divide by 5. And again, the last step is to square all this on the right-hand side, which give me 2 over 5 times y plus 1. 2 over 5 squared is just 4 over 25. Y plus 1.
I don't like seeing the double brackets. I prefer the line after, seeing it like that.
Going like here, yeah.
Yeah.
Yeah. And remember, this is
looks simpler.
This is a time.
Yeah.
So you need to put the wee time. What I found people writing the time the same as x, then they get lost and they go, is that an x? Is that a y? Is that a time? So you need to really tell them to write curly x's when they do x, especially if they use the time as a multiply.
Yeah.
Okay. And then you get a bit more complicated, but just the same step. Get rid of a add on 1, take away 1, and get rid of the 6, divide by 6. And after that, squaring the whole thing, y minus 1, and then add on 3. So you could leave it like that if you want to. 3 plus y minus 1 over 6 square. Or if you wanted to, you can still get the same mark if you were to do or. You can just say it's 3 plus y minus 1 square divided by 36 if you wanted to, because 6 times 6 is 36. So I need to get rid of my, to get used of my pen tablet, I was saying. So you can see that I'm still learning to write properly.
Santa dropped by Adrian's house and got a new pen
Left him
tablet.
a wee pen tablet.
That's
It's a bit slippery, you could see sometime.
You'll need to ask Santa if you get his receipt.
I know. Okay. So next, I would leave it y minus 1 divided by 6 square. It's probably better. So that I don't have to rewrite it. The next one, I've got 1 over root x. So what I would do when I get something like this, I would try to get rid of the fraction. I would, by timing root x on each side, you get y root x equal 1. That makes it easier for me. And then I divide by y, which is root x equal 1 over y, and then I square the whole thing, which is 1 divided by y square. Or you can say, oh, it's 1 divided by y square, which is 1 square divided by y square. So you can just leave it like that. That's much easier. So you do exactly the same for the next one. Time by root x both sides. Then I've got root x equal 4 over y, and then you square, which is 4 times 4 divided by y square. Okay.
Yep.
Then for k, so it's 2 root x this time. So again, bring in root x at the top, then divide by y, and then squaring the whole thing. So every term is squared here, 25 divided by 4y square. Okay. Next, I've got root x minus 1 I'm going to bring to the top, because 7 over 4. Root x minus 1 is 7 over 4 times y. Then you square you square both 7 and 4y, and then you add 1 to it to finish x on its own. Okay. So these are the hardest one you would get. These would be like for a A-type question mark. For the next one, it's again formulas. So make R the subject. I've got m plus 5 equal 4r square. So I'm going to divide by 4 first. Then I've got m plus 5 divided by 4. And then to get rid of a square, we take the square root. But in its simplest form, square root of 4 is 2. So you get your square root of m plus 5 at the top divided by 2. So that could be 2 or 3 marks. Next one, Q the subject, get rid of the negative f, which is plus f, then divide by 5, and then just take the cube root of I plus f divided by 5. And for D, they've asked us to make D the subject. So what you could do on this one is, first of all, have 1 over 4d squared equal v minus p. Then timing by 4d squared both sides, I've got 4d squared times v minus p equal 1. Then you divide by v minus p and by 4, which give me d squared equal 1 divided by 4v minus p, and then you take the square root, remembering that square root of 4 is 2, then you just get at the end 1 over 2 root v minus p. So from this, you can see quite a few steps to get me to this. Again, do you think you'll have people getting from this right up to the answer? I'm sure you could, but I would advocate that it's probably safer to go step by step so that you don't miss a negative or a positive or a square root. Okay. In that same manner, we had make y the subject. So make h the subject here. So I've got p equals 3 times root h minus 10. So I'm going to get rid of the negative 10 by moving it across. 3 root h equal p plus 10. Then you divide by 3, and then you square root to get rid of the root h. P plus 10 squared divided by 9. Next one, I've got g. They've asked me to make t the subject. So g equal q minus v root t. So I've time by root t both sides, remembering that it's the whole thing. So you need to put the brackets. Then g over q minus v equal root t, and then you square everything there to give you your final answer, g divided by q minus v square. And the last one, oh, there's another one. See, I've got r, the subject. Okay, so I'm going to get rid of the 2. 2 minus L equal pi. So then you divide by pi. Remember, pi is just a number. So 3.14159, etc. So you divide by pi. 2 minus L divide by pi. Then root of R over G. Then you do 2 minus L over pi square. And then you time that by G to get your R on its own. So the square only applies to 2 minus L over pi, not to G. And the last one, D, divide by 3 first, then square that. Then you can say, okay, I'm going to rewrite it as BH this time is equal to 3 square, which is 9 divided by V minus 4S square. And then because we're looking for B being the subject, you divide by H. That means 9 over H times V minus 4S square. I think the last one's probably the trickiest of the lot here.
Yeah, that's what I found.
Divide by 3, then square it to get rid of the square root. And after that, you deal with the time by BH both sides. Okay. So we've got another set of homework with the subject. I think we went through this one.
Yeah.
Gravitational force of attraction between two bodies. Where G, yeah. Oh yeah, it was to do with then finding out what the effect has got to. Yeah, so for gas molecules, this time we were given this V can be found with this formula, square root of, so here's square root. So what I'll do is, okay, make T the subject. To do that, we get rid of the square root first. So 3kt over m is v square. Then you time by m, you get 3kt equal mv square. And then you divide by, oh, v, yeah. Make T the subject, then you divide by 3k. And then that's you. You've got mv square. That's your first question here. Then they've asked us to make m the subject. So you could use this to make m the subject. Use the answer to this. So then you would time by 3k. That gives you 3kt equal mv square. Then you divide by v square. And that's you. You've got your second one. 3kt over v square. Because all these formulas here are exactly the same, but written with a different subject. Now, the question they've asked us is what happens to the velocity? So what happened to V? So I'm going to use the first one here. If the temperature is multiplied by 4, so if I, instead of T, if I put 4T here, what would happen? So you just say V equals 3K 40 divided by M. So square root of 4, you can get it out from this fraction, which becomes square root of 4 outside. Then it becomes just V equal 2 times what you started with. So if the temperature is multiplied by 4, your answer should just be the velocity is doubled, because now we got T times the original V here, 3kt divided by M. Okay. But some people don't need to do all this. They can just say, okay, I've got T, I've been asked to do 4T. But if I do 4T, root of 4 is 2, then that's 2 outside. And then they just say, oh, the velocity is doubled. You will still get the mark, even without showing all that work in there. Okay. Here, it was more to do with braking distance. So all these are using this math into context, into real application. Just before braking, the speed of a car can be calculating from its braking distance. So let's say you're investigating an accident, and what you could do is you see them sometimes measuring the skid marks on the road. And you might wonder, why are they doing that? So basically they use these mathematical formulae to just plug the skid mark in, and they'll be able to tell exactly what speed that car was running at within a certain percentages. So if the speed maximum was like 50 miles and they noticed that you were at 90 miles an hour, then you can see how someone can be quickly going into jail for, for something like this. Okay. Obviously, it's linked to conditions like weather is dry and good visibility, etc., etc. Okay. So now let's see with a little exercise. Calculate the speed just before of a break-in of a car whose braking distance is 240. Just means substitute 240 here. V is 2 times root 5 times 240 plus 25. So you can see with a 240 feet braking distance, the speed of that car was at 60 miles per hour. So you better start braking quite early if you see something happening in front of you. Okay. Then change the subject of the formula to D. So we're going to get rid of 10. So V plus 10. And then we're going to divide that by 2. V over 2 plus 5. Then we're going to get rid of the square root by making V over 2 plus 5 square. Then we're going to take away 25. And the whole thing at the end, we're going to divide that by 5. So you've got V square plus 5V plus 25 minus 25. So once you expand that, you can get rid of the 25. You end up with V squared over 4 plus 5V equal 5D. And your final answer is D equal V squared divided by 20 plus V. So change the subject and show that D, which is what they ask us to show. You can see that we've just shown that D equal V squared over 20 plus V. QED. Okay. Now, the maximum permitted speed on British motorways is 70 miles per hour. How much further would it take for a car traveling at 80 to completely stop? So you just replace the speed. So we've done that. You may assume ideal driving condition. So C is just the distance of at 80 miles per hour minus the distance when you're at 70 miles per hour. So the distance we found was v squared divided by v plus v. So using answer from B. So we've got 80 squared divided by v plus 80 minus 70 squared divided by v minus 70. So you plug that in your calculator and you end up with 85 feet. So if you travel at an extra 10 miles per hour, you will have an extra 85 feet of distance when you press your brakes. Okay. So show that the extra distance needed to stop when driving at p miles per hour compared to q. So remember we had 80, 70. So p is 80 and q is 70, for example, is given by this formula. So to do that, then you would just write the distance when we've got a speed of p minus the distance when we've got a speed of q, and then you just write it the same way we did, but with letters this time. And now we're going to have to use a common denominator, which is 20. So the common denominator here is 20 to put everything at the top. So in order to do that, we need to time p by 20. So that's 20p, and q by 20. That's minus 20q. And then you've got your p squared minus q squared plus 20p minus 20q. Or you can just say, oh, I'm going to factorize that. And this is where they're looking for you to observe that you've got a difference of two squares here. Remember when we did a squared minus b squared? It's a plus b times a minus b. So they expect you to see that and say, oh, I can rewrite this as p plus q times p minus q plus 20p minus q. And then you're going to factorize with a p minus q, p plus q plus 20. Oh yeah, so you've got p minus q times p plus q plus 20 because you factorize with p minus q. So that common factor here is just time all that together, which is what they ask us to prove. Okay, so that was a solving problem type solution. Okay. And I think that was it for the changing the subject of a formula. I'm gonna